you find the module evaluation. So you need to fill 2 documents. You need to evaluate the module itself and evaluate me as the teacher of the module. So please, is due today. Please go to link, you find module and teacher evaluation, click it, then you can find all those forms. There are 2. So you need to complete that before the end of tomorrow, actually, because it's due tomorrow. So please do. So I think that is just a quick announcement. Then from there, let's move. We are going to continue from where we stopped in the last class. And in the last class, if you remember, we started looking at deterministic inventory models. We talk about what is that topic all about? Why is it important? And what kind of questions does this module answer in terms of operations management? So we introduced that. Then we went there to look at what are the various categories of cost incurred in managing inventory. We ventilated that. Then from there, and most of you contributed to the discussion. Then from there, we went ahead to look at, the various assumptions. We went to look at one of the inventory models used to manage inventory, and we look at the first one, which was the economic order. I forget a quick announcement. Please take note that all the recorded class sessions that we have, because the university wants, they are saying us having those sessions recorded is clogging the system. So all those things now will be moved to OneDrive. So I'm going to save them on OneDrive. Then I will just provide a link. So that's what we're shown. So they don't want us to load videos anymore on Moodle. But definitely what they have told us to do is to take all the videos on OneDrive, then share the link. Then we believe you'll be able to access it. So that is the approach going forward. So the recorded class sessions for today, it won't be a video, but it would be uploaded as, what do you call it? The link will be made available. I'll just load it on OneDrive and make that link available. That's the instruction from the university. So please take note of that. So what I will just do is to create a new section, and I will just call it recordings for all our class sessions. Then I will just provide the link for those recordings in that section. So I will do that too. I will do that. I won't do that I will do those ones that I've loaded already, those recorded class sessions. I'll finalize it before the end of this week. Then for the class session for today, you won't see video anymore, but you'll be seeing the link where you can access the recorded session on what do you call it, on OneDrive that the university is providing. So please take note of that. So thank you, Brian. Thank you, everyone. Thank you, Ndikinda. Perfect. So I think with that being said, let's move on. So this tells you that they are monitoring our activities in terms of what we do. So I don't really know why they are saying that, but they said that is better because it's clogging the system. So let's move on. And today we're going to proceed. You remember we've looked at the assumptions of EOQ model, and that's where we stopped. And we said that one of the assumptions of EOQ model, we said when you apply economic order quantity model, it must obey. For you to say this economic order quantity model would help you to determine how much stock you're supposed to order, when you're supposed to reorder. Then all the assumption of the EOQ model in your work environment should obey this. That means the demand for inventory must be known with certainty, it must be deterministic, and it occurs at a constant rate, maybe on monthly basis or weekly basis or yearly basis. So if your organization have such situation, then we are good. So it must all these assumptions must be obeyed for you to use EOQ. Then we said if an order of any size Q is placed, an ordering and setup cost is incurred. So if the organization is incurring ordering cost and setup cost, especially in an organization where they are manufacturing the products, the inventory to consume them for the setup, then in that case, this can also be applied. If the lead time to place the order is 0, we talked about that. Then if no shortages is allowed, meaning that back ordering is not allowed and you incur some cost for inventory. So if all these 5 happen in your organization, then EOQ is the way to go. Then we discuss the behavior of how you consume this inventory after you get the order using this graph of how EOQ, model ordering and consumption work. So we stopped there. Then we said we are going to continue today. And the next aspect which we want to see today now is how do we know how many units of product should you order? So that because we said we incur various categories of cost. So what must be the amount of product that you must order at a particular point in time to minimize the summation of all this cost? And that is used under the EOQ. And that will lead us to some derivation here. But for the online test, you don't need to worry because you won't be asked to prove. But I can ask you what is the mathematical expression for the ordering cost, for the total ordering cost, for the total inventory holding cost, for the total purchasing cost, or for the inventory item. What is the mathematical expression for that? What is the economic order quantity formula? So I provide options. So if you don't know the proving, you cannot answer those questions. So take note of take note of that. So with that being said, we are going to look at that proving so that we can use that to derive. And that is actually how we arrive at the economic order quantity formula to say how many units of product should we order when we place an order in such a way that we minimize the total ordering cost plus the total inventory holding cost plus the cost of purchasing those inventory items that we are ordering. So how do we derive that Q, which is the economic order quantity, that will make us ensure that minimum total cost? So that's what we want to see. So I'm going to stop sharing, then before I stop sharing, just to highlight to you, remember we said the various categories of cost you incur based on those assumptions of the EOQ model is ordering cost. You're incurring ordering cost because you place the order. Then for you holding inventory, then you incur inventory holding cost. Then because you also want to purchase the item, you also have the purchasing cost. So we want to find what Q will minimize the summation of all these three. So, and we are going to do the derivation together now. So if I should show you my Word document, so I will just flip between Word document and the note itself. So like we said, what we want to find out is how to minimize this total cost. So we want to derive now that economic order quantity that will minimize this total cost. Total cost, which is equal to your ordering cost, which is the total ordering cost plus inventory holding cost plus purchasing cost. So mathematical expression for this, we need to derive it. Inventory holding cost. So let's start with the ordering cost so that you can know how I'm getting. If I want to know what is the total ordering cost, which will go into that into the formula. Total ordering cost. Mathematically, who can tell me how do we know the total ordering cost? If I want to know the total ordering cost that I need to place in a year, who has an idea of what that would be based on simple cost accounting? Let me just help you quickly. It's a function of how many orders you are placing. So let's just say how many orders, total ordering cost per year. So we are looking at it annually. So what is the number of orders placed, maybe per year or per month? multiply by the ordering cost per unit item per year. So this is number of orders placed in a year. So mathematically, we assume that if capital D is the annual demand, if capital D is the annual demand for those inventory items, and you are saying Q, let's say small letter Q is the number of inventory item that you want to, number of inventory item quantities to be ordered at any point in time, then it means in this case, the number of orders to be placed per year, number of orders. And don't forget the ordering cost. We said the ordering cost is K according to the assumption. So you can take note of that, which is per unit, ordering cost per unit per year. It's capital K. So based on this now, think about it. If I want to work out the number of orders mathematically, number of orders to be placed is a function of number of orders. It will give you, insert, let me put an equation. So it will give you D over Q. And that is, how am I getting this? Think about it. If maybe your total annual demand is 1,000 units for a particular item, and you place an order, and you are now, how do I call it? You place an order for maybe 20 items every ordering phase. So that means the number of orders you place in a year, let's just say you place an order of 200, and your total annual demand is 1,000, which is D. You place an order of 200 every ordering phase, which is Q. So that means the number of orders you place per year, based on that simple logic, will give you 1,000 over 200. And that's also what we are saying. To say number of orders you place per year is D over Q. So I hope that makes sense to you. So the number of orders will be D over Q. And that means based on this now, it's easy for you to work out the total ordering cost. And that means based on this, the total ordering cost, which goes into the total cost equation when we get there. Total ordering cost, we give you D over Q. To give you D over Q, because number of orders placed now is D over Q, so you can put it into the formula. So that will give you D over Q times ordering cost per unit item per year, which is K. Why is this not showing? Coming. Okay. It will give you D over Q times K. Times K. Maybe let me just put it outside so that D over Q times K. So that means the mathematical expression of your total ordering cost. If you are asking the online test to say the mathematical expression of the total ordering cost is what? So the final expression for that is dk over q. And I give you options, so you must be able to select the right answer. dk over q. Then from here, Does it make sense up to this stage before I move on? If it makes sense, type Y before I move on. Okay, Nikinda, thank you. I'm waiting for everyone to confirm. Thank you, perfect. Good. So then don't forget, we've worked out the ordering cost. Thank you, Sianka. Thank you, everyone. Perfect. So it makes sense. Good. So we've worked out the ordering costs, mathematical equation. We need to also follow the same principle to work out the inventory holding cost mathematical equation. So if I bring this down, because we need the mathematical equation for each of them to now come up with the final mathematical expression for total cost. And now we need to go and find the Q that minimizes that total cost. And that's where differential principle comes in. But I will show you when we get there. So the inventory holding cost in this case is equal to the average, average inventory, or the inventory, you can see what you can say is the inventory quantity held and used over a particular period of time. Because now we want to work out, don't forget, depending on how many units of inventory you are holding times the inventory holding cost per unit. And the inventory holding cost per unit. So, and don't forget, inventory holding cost per unit will represent it as H based on the assumption of the EOQ model. So we can already say the inventory holding cost per unit is equal to H. So, but what is the mathematical expression for the inventory quantity held and used over a particular time period? I will tell you how we generate that now. It's not difficult. So what will be the mathematical expression for this? So the mathematical expression for this is, for you to know it, I will have to show you in the diagram. Based on the diagram of how EOQ behaves, you remember we talked about that? If you go back here, you remember we said here, this is the way EOQ behaves based on its assumption. When you place an order of Q, don't forget you are starting with 0. You get Q, then you consume that Q over time. They will be reducing until you get 0. And since lead time is 0, you can consume up to 0. So that when you place the order at that point in time when your inventory is finished, you can receive it immediately. That's why the lead time for each order is 0. Then it shoot up like that to queue back again. If you have ordered for queue, then you consume like that and buy again in that order. So it means that we need to go, and if I want to know what is the inventory holding cost, I need to find out what is the amount of inventory that I'm holding when I get queue and when I bought queue and that queue is reducing over time. So it's actually the area of this curve, because that is when you bought queue and you consume it up until you get to 0. So this area, which is that triangle, that is the area where you have inventory available up until before it reaches 0. So that is the inventory held and used over time that we're talking about. And that means for me to get that average, that inventory quantity is the area of this triangle. So I can use the formula of the area of a triangle, which is half base times height, to work that out. So, and that will tell me the inventory that I'm holding. Then over time will be divided by that time period. And each time you are seeing on the horizontal axis, from 0 to Q over D, that is the first, is T over a particular time period, maybe which is the time to consume the first order for T1, then this is T2, and so on and so forth. So that means I need to work out the average, work out the area of this triangle to know the inventory held and consume over time, and that will give me based on the area of a triangle formula, you know that is half base times height. Then take note, this Q over D is more of T because it's like you are consuming inventory over a particular time. So this is the first T1, like then the second one is T2 after the second ordering phase and so on and so forth. So you look at these as T. So if I want to use my half base times height, so my base is from 0 to T, which is that T. That is half times T times height, which is Q. So that will give you half Q, half times T times Q, and that is the area of this triangle. Then over time, then you divide it again by T because we want to know, because the only thing we have done so far is calculate the average inventory held, which is half times Q times T based on half base times height. Then you consuming that half times Q times T over time, then that will be divided by T. So mathematically, the inventory quantity that you have held and consumed over time, it will give you what I've said now. So I'm going to share because I think I've used that diagram to explain how I'm deriving the mathematical expression. So that will give you insert need an equation. So that will give you half, because it's half base times height, and we have seen it is half times, based on what I've explained to you, half times base was T times, let me just put it like this, insert, so that is half, because that is finding this one is helping you to find the area where you consume the inventory, which is that triangle. You bought and consumed the inventory, so that is half times T times Q. This is half base times height over a particular period of time, which is over the first ordering cycle time. So over that particular time T. So that means mathematically T, we cut T, and that means this is reducing to half, this is reducing to half Q, if you look at it. So the formula for average inventory held over a particular period of time is that formula half T times Q over T. I've explained that. Then multiplied by the inventory holding cost per unit, which is represented by H based on the assumption of the EOQ model. So if you simplify this further, you see that the inventory holding cost mathematical formula, inventory holding cost mathematical formula is equal to, because T we cancel T, so that means you are going to be left with 1/2, you can say Q/2, QH/2, if you simplify it. So that is Q/2 times H. So because T will cancel T. So any question with this, does this make sense in terms of the inventory holding cost? If it makes sense, type Y. Please respond. Thank you. Thank you. I see the reactions. I hope it makes sense up to this day. Thank you. Okay, perfect. So that will give us that. So that means based on this now, we're almost there. We've calculated the mathematical expression of this inventory holding cost. Thank you. Thank you. So the only one which we are left with, and I told you in the test, I can just say what the mathematical expression for the total ordering cost for an economic order quantity model is, then I provide options. So you must be able to know The mathematical expression for the inventory holding cost for an EOQ model is the mathematical expression for the purchasing cost is I provide options. So if you are not in class and you don't understand this, then you'll be in trouble. Then the next one is purchasing cost. Purchasing cost. So this one is very straightforward. Purchasing cost for those inventory items is a function of the number of inventory items from cost accounting, number of inventory items ordered, multiply by the price, the selling price, né? Multiply by the selling price per unit inventory item. So based on this one is very easy. So number of inventory items, and this is like number of inventory items you ordered yearly, multiplied by the selling price per unit inventory items, which is the cost per item. So we represent that as the annual demand, because we want to know the total, let me just say annual purchasing cost, because everything is done annually. So the number of inventory items ordered annually is annual demand, which is D, I've told you previously. So then the selling price per unit, which is the cost of buying the item, it as C. Or we can just call it cost of purchasing. Of purchasing an inventory item. So this one will represent it as capital C, cost of purchasing an inventory item. We represent it as C. So based on this now, the purchasing cost mathematically, it will give you DC. So that is the mathematical expression for the purchasing cost. That will be D times C. And that purchasing cost mathematical expression equal to DC. And that is what you are seeing in the notes. When you go to the mathematical expression for the total cost, so you see this will give you DC. So that means the final mathematical expression for your total cost. So if they ask you what is the mathematical expression for the purchasing cost is DC, so I'll give you options, so you must be able to select the right answer for the online test. So I'm already telling you the possible questions you can have in that online test. So it talks to all these steps. So if you're not in class, I wonder how you get it right. So that means now I can get the mathematical expression for the total cost now, and now go and find the Q that minimizes that total cost. And that will be the economic order quantity formula we want to derive. That tells us how many how many inventory items should we buy at every ordering cycle, if those assumptions of the EOQ model are obeyed in our organization. So ordering cost mathematical expression, we have seen it as dk over q So what I will do is I want to bring the k to bring it outside, still the same. Then plus inventory holding cost is QH over 2, so I'll make it Q over 2H so that I can just separate it so that I can see. This is what I'm separating. I want to see where the Q's are. So Q over 2H, which is same as KH over 2. Then plus the purchasing cost is DC. So if I can also ask you in the test, what is the mathematical expression of the total cost incurred by an inventory manager whose inventory behavior follows the assumption of an economic order quantity model. So this is the mathematical expression. So I can also ask you and give you options. So you must be able to select the right answer. So like I told you, all those questions I'm asking, if you have gone through those sample questions, it talks to all those steps that we follow in class. So if you are not in class and you have not done all those questions, then you are in trouble. So even if you are doing it at home and you are not in class, is a problem. So here now we want to find out, so we represent this total cost as TC, so that it's easy for us to do the mathematical formulation further. So what we want to do is to find TC, that find the minimum, find Q. So we want to find how many should we order, which is Q. Find Q that minimizes the TC. So anytime you are trying to solve this, you have to apply differential calculus. So it means that you need to go and differentiate, because I want to differentiate the total cost with respect to Q, so that I can check through that experiment to see. Anytime you want to do this, anytime you want to do this kind of experiment, you run these steps, carry out these steps, carry out the following step. If you want to find Q that minimizes TC, the following steps. And the first step is step 1, determine that is differentiate. You want to determine the TC, the Q. So that means you want to differentiate TC with respect to Q. That's the first step. You have to determine the T, we call it small letter t. So anytime you want to do this, we call it differentiation. You see when we get into nonlinear programming, but for now, we just want to introduce it to some extent. So you differentiate your total cost. That D you are seeing in front means that you want to differentiate with respect to, you differentiate that with respect to Q, that you want to know that Q that minimizes the total cost. So you have also D, meaning that you want to differentiate also with respect to that Q. So that is the first step. Then step 2, you need to go and differentiate. You need to differentiate the TC, the Q for the second time, meaning that you need to go and find D squared meaning that you want to differentiate TC with respect to Q for the second time. So you're looking for D squared TC, the Q squared. Then you now proceed step 3. You need to check whether your D squared TC, whether your D squared TC, the Q squared is greater than 0. If yes, then this result, because we are running the test to see whether, based on that total cost expression that we have on top, will Q minimize it that. For you to run that test, you have to differentiate TC with respect to Q twice. And that's where you get to step 2, then you check what is the result of what is the sign of your d square TC, d Q square. If it's greater than 0, meaning that it's positive, it means that if yes, then it implies that the Q you are going to get from this total cost formula, total cost expression formula, it means that the Q to be obtained from the TC dq, from the TC dq will minimize the total cost, to minimize TC. This is the total cost. But if it can be negative, it means that it will maximize it. And that means that Q will not minimize. So let's go and check whether this d square TC dq square, if we do that differentiation, whether it will give us a positive result. If it gives us positive result, it means that actually the Q we are going to get from this dTC dq, it will minimizes the total cost, and that means that Q will now become the economic order quantity, which is the EOQ formula. So the last step, if that rule is obeyed, now you can now set the TC dq, and set the TC dq, you can set the TC dq to be equal to 0, and make Q the subject of the formula, obtain the value of Q, which becomes the economic order quantity formula. Economic, which is the EOQ formula, which most of you have seen in your second year and all those. So, but this is how it was derived. So it becomes the EOQ So let's do all those steps, and also in the test, all the steps that I highlighted, I can ask you the following are the steps that you need to follow when you want to determine if your Q minimizes your total cost during the formulation of economic order quantity formula. So I provide all these steps. I will give you maybe the one which is not part of the answer. The following steps are the steps, except then you must look for the step which is wrong. So please make sure you master this. It can also be coined in form of a question for the online test. And I hope you are noting all those possible questions. So does it make sense up to this stage before we go and do all those steps now? Because we are going to do all this step 1 to step 2 to go and find the Q that minimizes the TC. Please, let's respond. Don't keep quiet. Thank you, Sakiwe. I hope it makes sense. Thank you, Nulutando. Mashlango, I hope you are there. Thank you, Nechada. Yeah, it's fine. So Ndala, thank you. I think it makes sense. Let's move on. Good. So now let's go to step 1. They said find the TC dq. That means we differentiate this TC from TC equation with respect to Q, and I will tell you how we are differentiating. It's not difficult. I know even if you did pure mathematics, if you did math literacy, what I'm going to show you now, is you just follow it to the letter. So it's not difficult. That's why I'm taking it slowly so that you understand it. So when you differentiate, don't forget, we want to differentiate TC. We want to find this. So if you look at what we are saying there, it means that we are differentiating TC with respect to Q. So if you do that, what you first need to do is to make sure that you represent, because when we differentiate, for example, Y, let me just give you, for example, if Y equal to, just to show you how to differentiate, X squared maybe X raised to power N, and I want to find the Y dx, then if I want to differentiate Y with respect to X, just to show how you differentiate, then your dy dx, that means you are differentiating Y with respect to X, then the Y, the X, it will be equal to, so it will be equal to, the way we differentiate this, you look for the coefficient of X. Don't forget, X raised to power N, the coefficient is like 1. So you can even look at it as 1 X raised to power N because coefficient is 1. So when you differentiate anything like this, you take the coefficient of that expression, you write it down, you put a bracket, you say 1 times, you go to the power of that equation that you are differentiating, you note the value in the power, you bring it down, 1 times N, then you bring the X raised to power N back, which is same as 1 X raised to power N. You bring that equation back of X raised to power N, you bring it down again, showing you how to differentiate. Then you subtract the value of what you brought down, go to the power, you subtract the result by 1. So that's how to differentiate. And that means mathematically, this will be equal to, this will be give you N X raised to power N minus 1. And X raised to power N minus 1, and that's the mathematical expression for that. So if I follow the same principle now, don't forget, I want to differentiate TC with respect to Q. So it's better to make the expression of this thing look like this, to be in form of Y equal to X raised to power N. So I can quickly see this and say I can split this, because I want to make the Q to be on top, so that it can look like something in form of X raised to power N. I don't want to be fraction. Then I can follow that principle to the letter. So mathematically, you can see this is more of capital D times 1 over Q, because I want to simplify this so that it can be Q raised by something and apply the law of indices. Then Q over 2, don't forget Q is like alone. I can bring that H over 2 out and say, and bring Q separately, because I want to differentiate that Q. So it's just a matter of rewriting this and say this is becoming H over 2, then this is becoming Q, still the same thing. So, but I just want to Q to be a standalone. Then the last one doesn't have Q, so I can write it back, which is DC. So now I can rewrite this. So I will say for now, I'm not rewrite because this is TTC. I'm just trying to re-express my TC so that Q can stand alone. I can then make Q not to be in fraction, but to be a standalone item. So then from here, I can say TC equal to, don't forget, this will give you capital D times 1 over Q according to the law of indices is Q raised per minus 1, if you still remember. So that will give you, and that's what I want to simplify it to, so that everything is in form of, it's not anyone, nothing is in fraction. That will be times K plus already H/2 times Q. Q is not a fraction, so that one I'm fine with it. Then DC doesn't have Q, so I can repeat this back. Now I can now start differentiating. Don't forget, this DC doesn't have Q, so this DC is more like a constant. So when you differentiate a constant, maybe 3 or 4, any number that you are not differentiating with that variable, and that variable is not there, when you differentiate any variable that doesn't have the variable you are differentiating with respect to, when you differentiate that variable, it will give you 0. That is the rule. So since DC doesn't have any Q in it, it's more like a constant. So when you differentiate it, it will give you 0, meaning that the purchasing cost doesn't really influence the inventory holding cost, because whether you like it or not, and the meaning of that is whether you like it or not, whether you hold inventory or not, you still need to purchase the item at any time you need it. And that's why when we differentiate it, it's giving us 0, meaning that it doesn't influence how the inventory cost, whether it increases or decreases over time. So take note of that. So that means based on this, now I can differentiate and find the TC, the Q, find the TC, the Q. So if I find this mathematically, this will give me, now I can bring, maybe I should just rearrange this so that I can bring only Q to be on the last end, because this DK, you don't need to worry much about differentiating. They are more like a constant in front of the Q. So I can just say this is DK, so that Q is the one in front. Then it looks like this. So that means when I differentiate, I'm differentiating with respect to Q. So this DK, you bring it down. When you differentiate, it's more like a constant. I'm differentiating with respect to Q, applying that law that I've shown you to say when you differentiate x raised power n, you follow the principle to the letter. When you differentiate this will give you the coefficient of Q raised power minus 1 is 1 times, then minus the value on top is minus 1, then you say minus 1 times minus 1, then Q raised to power, we are following the same principle of how you did the dy dx differentiation from x raised to power n. So this will give you Q raised to power 1 minus 1. Following that principle of differentiating from dy dx. Then when I differentiate h/2q, so this q, if you should look at it, is more of q raised to power 1, so that it's easy for you to follow the same principle to differentiate. So this q is coming. So this q is more of q raised to power 1, which is still q. So if I follow the principle in terms of differentiation, just differentiate the q part, bring the h/2 down again, like we did with the first one. So this will give you into bracket. Don't forget the value in the power is before you go to the value in the power, the coefficient of q raised to power 1 there is 1. So you say 1 times 1 times, then the value in the power is 1 also. Then you can bring this q raised to power 1 minus q raised to power 1, then you subtract 1 from it. Based on the law I've shown you to differentiate, you copy this and you place it down, so that will give you q raised to power 1 minus 1. Then when you differentiate DC, I told you it doesn't have Q, it will give you 0. Anytime it doesn't have the variable you are differentiating, it gives you 0. So now you can simplify this and say the TC, the Q, the TC, the Q would give you 1 times minus 1, so that will be minus DK then q raised to power minus 2 plus it will give you h over 2 times 1, which is h over 2, then q raised power 0. Anything raised by 0 according to the law of indices is 1. So that will give you 1 times 1 times h over 2. So that means you are left with h over 2 here. Plus 0 is nothing. So that means the final expression for your DTC, the Q is this. And you can simplify this further and say, don't forget, Q raised by minus 2 from the law of indices is 1 over Q raised by 2. So I can already say here, my final expression of the TCC, the TC, the Q would give me this into bracket 1 over q raised by 2 from the law of indices, because a raised by minus m is 1 over a raised by m. That will give you 1 over q 1 over q raised by 2. And now you can close the bracket and say plus h over 2. This is just to simplify it to the last simplification. So that is the TCC. So the next step is saying, if you go and find the square TC, the q squared, which is step 2. So that means you take the result of your DTC, DQ, you differentiate it the second time. So that means I'm taking step 2 now. We're almost there. This is where we want to test whether the Q will minimize that TC and see whether that result of the square TC, the Q square will be positive. If yes, we are good. So we take the squared, the DTC, the Q, so you can take any of those answers. I prefer to take the second one so that the expression is already Q standing alone and is not in fraction. So I'm taking the second one. Then I want to differentiate from here a second time, which is the second differentiation. Why? That's why you are seeing it as the square t squared, the q squared. So now we want to differentiate this, the tc, the q for the second time. So if I differentiate this mathematically, it's very easy. Following the same principle, it will be minus dk. You know how to differentiate following how I differentiate dy dx. The quotient of q raised by minus 2 is 1, so that will give you 1 times, if you have mastered the procedure, times the value in the power is minus 2, so you bring that minus 2 down, following the same principle. Just follow it to the letter. Then you bring that q raised by minus 2, let it repeat itself. Then you subtract 1 from the value in the power. That's how we do it. So that is what you have there. Then when you differentiate h over 2, it doesn't have q. Anytime you differentiate a value that doesn't have q, I told you it will give you 0. It doesn't have the variable of interest that you are differentiating with respect to. So that will give you 0. And mathematically, if you simplify this now, let's go and see whether that d squared tc, this q square will be positive expression. If yes, it means that the q we are going to get from the tc, the q would minimize the cost. And that's the essence of running this test. So mathematically, this will give you minus dk times minus 2, that will give you 2 dk into bracket q raised by minus 3. So dk into bracket q raised power minus 3. Then from here, you can see if I simplify this finally, this will give me d squared tc dq squared equal to 2dk over q raised power 3. So that means I can say this would give me, because q raised power minus 3 from law of indices is 1 over q cubed. So I can just follow the same principle like I did here, using the law of indices. Then this will give me 2dk over 1 over q cubed from law of indices. So the final expression, if I combine everything for this, it will give me 2dk over q cubed. That will give me 2dk. So if you look at this, this is the final expression, and you can see the result of d squared tc dq squared. Now, after we have got it, we need to go and check that to say, is that expression, is it greater than 0? Is it positive? If yes, that means the q we are going to get from the tc dq will minimize our cost. So if you look at what we have here, is 2dk. So this is like annual demand, which will be a positive value. K is ordering cost. Q is also like how many products you want to order. So you can see that value is positive. So you can now say, since, because we didn't have any negative in front of it. So since d squared this is positive, that is giving you this result, which is positive. That is this equal to this. Then the Q to be obtained from setting the TC dq to be 0, which is the next step. From setting the TC dq to be equal to 0, will minimize the TC, the total cost. And that's the essence of running the derivation twice. You go and see from the square TC, the Q square, whether it's positive. So if it's positive, then it will do that. So then we can proceed now and go to step 3, where you set the DTC expression, because you see that from the test, any Q we are going to get from DTC, the Q will minimize the cost. Now you go and set the DTC step 3. We now go to our, step 4. Don't forget, this is step, let me see. We've done step 1, we've done step 2. Now we are going to step 3. Step 3, we have done that now based on this expression in terms of concluding whether it will minimize. That is step 3. Then step 4 now, based on what I've shown you there, you now set DTC dq to be equal to 0. So go and set the expression of your DTC dq, which was this result. I can set it to equal to 0 and go and make Q the subject of formula. So any Q I get from there will be the economic order quantity formula. So that means you set this to be equal to 0, We're almost there. So that means now you can bring this and bring it down. And after setting this, means that now you make Q the subject of the formula from here by collecting the like terms. So you can say this equal to this equal to, so you can take h/2 to the other side, or you can just do it like this. Let's say you take this expression to the other side and leave h/2 here. Anyone you want to do is equal to 0. If that negative dk plus what goes to the other side, it becomes positive. You know the rule of collecting the like terms. So if I take this to the other side to become positive here, that means this would be plus. Now that means you have got h/2 equal to, let me just write this as dk over q squared, so that it's easy to cross multiply. Dk over q squared, then you can cross multiply from here. Because we want to make q the subject of the formula, you know how we do this simple mathematics. So that will give you h times q squared h times q squared is equal to 2 times dk. 2 times dk. So that means based on this now, this will give you hq squared. So this will give you hq squared equal to 2 dk. Now make q the subject of formula by dividing both sides by h. You see, this will give you q squared. We're almost there now. Q squared equal to 2 dk over. Yes? Is there someone talking? If you have questions, feel free to ask. So this will give you, yes?
It will give us 2 dk over h.
2 dk over h, thank you. So I want to just, because don't forget I'm using word here, so it's just to f that 2 dk over h. And that means based on this now, we can find the square root of both sides, because if you find the square root, that's when you can get q. Find the square roots of both sides. If you do that, this will give you, so I will just put everything inside the square root. Square root of this equal to, so let me put everything like this. Go to this, so I can go and copy this because I want to find the square root of that. Copy, paste it inside, find the square root of this also, so that you can get q. And that means based on this, now you have q, which is equal to this square root of 2 dk or 2 kd over h. And this q now, this q, because it's the q that minimizes the total cost based on our experiment, you change it to become EOQ. That EOQ is the same thing as your Q that you have obtained, because this is telling you this is not an ordinary Q, but it's an economic order quantity, which is telling you the economized quantity that you must buy so that you minimize your total cost, so that you don't overstock or understock. So, and this is the formula we use to solve any inventory problem that assumes all those assumptions. So, and this is the formula we use, and most of you are used to this formula, but you just use it for every problem, but it doesn't mean you need to use it for every problem. So you need to check whether that inventory problem, does it obey those assumptions of EOQ? If yes, that's when you can use this formula. So any question with this? I hope it makes sense. With the other inventory models, we are not going to do the proving, but this is just to do the proving for one for you so that you understand the mathematical interpretation of how you determine the Q that help you minimize the total cost. But the same logic can be applied for other inventory models. But with this, I think you have an holistic view. So that the other ones, we just talk about the context and show you the formula. So does it make sense up to this stage in terms of the formula? Before I can now maybe summarize all the possible questions for the online test on this. Thank you, Mabuza. Thank you, Sakiwe. Does it make sense? Everyone up to this stage, Brian, Nechada, Mabunda, I hope it makes sense up to this stage. Good. Good. So what are the possible questions we can have here? Because I always try to tell you, especially for the online test, how could the questions come from this derivation of the EOQ formula? I can ask you questions that says the various component of cost that you incur in an economic order quantity inventory models are maybe dash, dash, and dash. So I can provide options. Or I can say maybe they are maybe they are the various costs include all the following except. So I can provide all the options, then you must look for the odd one. So that means before you can answer that, you must know what we did in class. Another question which you can be asked in terms of in terms for the online test, you can be asked, like I told you, what is the mathematical expression of the total ordering cost? You know, and I give you options, you must be able to provide the right answer and select the right answer. I can ask you what is the mathematical expression for the inventory holding cost. You must be able to do that. So like I told you, all the questions I was asking test, I would have said it in class, and I hope you are noting it. So if you are not in class and not, for those people that miss the class, they have to listen attentively to the recording. The mathematical expression for the purchasing cost is I provide option. So you must be able to know that the answer is DC. Another question you can be asked, the mathematical expression for the total cost when you derive the economic order quantity formula is, you must be able to select this answer if you have that as part of the options. Then I can ask you, like I told you, the following steps need to follow when you want to find the Q that minimizes TC except. So I can provide all these options and provide the odd option, or one of the steps that you follow when you want to find the Q that minimizes TC is dash. I can give you the right I can give you a lot of options, and one of them will be talking to any of these steps. So please take note of that. Then I can also ask you, the TC DQ is equal to, is your differentiation of the total cost with respect to Q, which is the TC DQ, during the course of deriving the EOQ formula is, I provide option, you must be able to select this answer or this, any of this, it's fine. So I'll provide any of these as the option, so you must be able to select that. I can also ask you the mathematical expression of total cost with respect to Q when you differentiate it twice, which is the square TC, the Q squared is what? You must be able to answer that. Provide the right option. So you can see I can ask many questions. I can also ask you what is the EOQ formula? The EOQ formula, the economic order quantity formula for inventory problem that obeys the economic order quantity inventory model is, the EOQ formula is what? So you must be able to select the right answer. So those are the possible questions you can have on this for the online test. So I hope it makes sense because I'm trying to make life easy so you can see how the question can be phrased in the online test. Does it make sense before I move on? Just use a reaction if it makes sense in terms of how the question could work. Come in test, okay, it's fine. In the online test. So good. So another thing you remember, we said thank you very much. Good. So it means that at least we'll be able to answer, at least come up with a formula that can answer the first question that inventory problem, that inventory decision help us to answer. Remember we said we want to know how many should we order at a particular ordering phase, which is now the EOQ formula, which is square root of 2dk over h. If all those assumptions of EOQ models obey for that inventory problem. So remember there are some other questions that we also need to answer, like what is the reordering point? When should we reorder? We need to also derive that formula, but we won't prove the formula, but I will just give you the formula for that. And we are going to see an example of a problem that obeys the EOQ and use all this formula to solve that inventory problem. So the next one is what is the number of orders we must place a year? I think we have seen that when we're deriving. So anytime you are trying to determine the number of orders, so let me just highlight this. This is the big formula, final formula that we use in some problems that we solve. So I'll make it bold. So take note of that. You use that. The number of orders will be placed per year. You can also have that in the question which you see. We have seen that as D over the formula for that. If they ask you how many orders should you place a year based on your EOQ, the formula is annual demand over the EOQ that you have calculated. So you can also be asked a question on this. Take note of that. You see when we look at an example now for EOQ, for an inventory problem that obeys the EOQ assumptions. Then the other question is, what is the reorder point in terms of at what time should we reorder for EOQ based on at the rate we consume our EOQ. So when should we place an order? When should we reorder? Reorder point, we call that reorder point. When should we reorder EOQ, which is the economic order quantity? When is the next ordering phase? That's reorder point. And the formula for that is EOQ over D. It's just the opposite of this. And you use all this formula if all those four assumptions of EOQ model are obeyed. EOQ over D. So those are the formulas. So we try to look at an example now. So all these formulas, they will be very important when we look at an example. So after we look at an example, we look at some tutorial questions in the textbook in line with this, so that all these quick examples and tutorial questions, let them be your friend in preparation for the test, which is coming up next week. So let's look at now, I think with the derivation, you know that, and we know the key formulas associated with making inventory decisions if the inventory problem follows the assumption of the EOQ model. So let's go back to the note and look at an example and see how we use this formula to solve inventory problem. So I'm going to take you there. So we are going to see an example here. So let's try to look at an example of the Brain East Airlines. And we see how this inventory problem is being solved. And how did we know that this is an EOQ, that an EOQ model, inventory model can be applied here? So let's see and let's read it. They said Brain East Airlines uses 500 taillights per year. Brain East Airlines uses 500 taillights per year. So you remember we said D is the annual demand. So that 500 taillights per year is your D. So that is capital D, because you need to read in the scenario what is your D, which is the annual demand. So the number of taillights they are using in that airline is 500 per year. Every year it's always be constant. That's what they are saying. And they said each time an order for taillight is placed, an ordering cost of $5 is incurred. That will be our K. So we have seen our capital D to be 500. Ordering cost we represent as K. You remember when we were doing the proving. So K will be $5. Take note of that parameter. And they told you that each tail light cost 40 cents. So that is the cost price of buying the light, which will represent as C. So your C is 40 cents, which is 0.4. So you can take note of that. And they told you that the holding cost is 8 cents per light per year. So that means H, which is holding cost, remember, is represented by small h. So small h will be 8 cents. If you convert that to dollar, because it must be in dollar, that will give you it over 100. So that's why you see in the parameter that they are writing there, they said h is 0.08, because 8 over 100 in the calculator will give you 0.08 per light per year in dollar. And we have seen the annual demand being D, which is 500. We have seen that. They said, assume, look at it, assume that the demand occurs at a constant rate. You can see this is one of the assumptions of the EOQ model. And shortages are not allowed. And it's also assumed here that the lead time is 0. So already you can see that this is an EOQ problem. The first question which they're asking you, and they didn't even tell you, even though they didn't tell you that the lead time is 0, they didn't tell you that the lead time is maybe 5 weeks or something. So that means when they place the order, they get it immediately. Because if there is an obvious lead time, this also stated. Hence, it's also assumed that the lead time is 0. So you can see all those assumptions that we state for EOQ is obeyed here. The first question, so based on that, I know I'm using EOQ formulas or EOQ model to solve this inventory problem. So the first question is, what is the EOQ? What is the economic order quantity? So we've determined the EOQ as square root of 2dk over h. So it's easy for you to see that actually this Q star you are seeing there is the EOQ. So they call it Q star in the textbook, is the same as EOQ. Then square root is that raised to power half, because square root according to the law of indices is raised to power half. Then 2 times k times d over h. So remember, if you apply the formula, that will give you square root or raised to power half, anyone you want to use, times 2 times k, which is 5, times d, which is 500, over h, which is 0.08. Then you can press calculator. Then the EOQ will give you 250. So does that make sense? Please confirm. So you can also press the calculator. Yes, in the kinder.
Hello, sir. So what if the 500 was not annually? What if the 500 was like in monthly basis?
You have
So
to
instead of
convert it.
to a
If they
year.
tell you, yeah, you see, that's a very good question. I will show you an exercise. You see, we are going to look at some exercises that you try at home. Sometimes they give you monthly demand. Some students will now use monthly demand as D. And don't forget, D is supposed to be annual demand. That's a very good question. So you have to convert it to annual, because all the other parameters are yearly. All the parameters must be yearly. So you have to convert that monthly demand to annual demand. If it's maybe weekly demand, you convert it to annual demand depending on how many weeks you have in a year. So please, that is a very good question. Please always convert.
Thank you, sir. And about the lead time, what if you were given the lead time on your statement?
Yeah,
So
we'll
where
see
would
that.
it?
We'll see
Okay,
that.
cool.
Because if you look at this example, actually, if you look at it, it doesn't really, is not really realistic to say when you place the order for tails light, then the lead time is always 0. When you place the order for lead time, it might, you place the order, the lead time to get the order might take some time. So actually, we need to factor in that lead time. You see now they modify the example in the later examples. But in this case, the example is assuming that EOQ is, the lead time is 0, so that it obeys all the assumptions and we try to calculate. But if the lead time is not 0, you still use the EOQ formula, but you need to modify the result to be able to factor in the lead time to be able to, it won't affect the result of your EOQ in terms of how you order, but when you reorder, will be affected owing to that lead time problem. But EOQ, whether there is lead time or not lead time, EOQ result will be the same. You still use the EOQ formula. But the only thing that would change if there was a lead time, which is what happened in real life, is that the reorder point result when there's lead time will not be the same as the reorder point result for case where there was no lead time. You see when we get to that case. So Ndikinda, I hope I'm making sense.
Yes, you are, sir. Thank you so much.
Okay, perfect. So if you look at this, so our EOQ is 250. That is very straightforward. Then the next question is saying how many orders will be placed each year? So how many orders should we place each year? So that is the number of orders per year. I've told you the formula. The formula is just your annual demand over EOQ. And that's why you see them saying is D over Q star, which is same as EOQ. And the annual demand is 500 over EOQ, which is 250. So the number of orders to be placed per year is 2 orders. So you can answer that easily. Then the next question is saying how much time will elapse between the placement of orders? That's the reorder point to say, after you place the first order, when should you place the next order? So when is the reorder point? That's the question that they're asking there for the third question. And the reorder point is Q star over EOQ over D, which is Q star over D. So, and that means you get 250 over 250, which is your EOQ over D, which is 500. And that will give you half. Any result you get is in year, because don't forget all the units are in year. So that means your reorder point is half year, which is, if you convert it to months, that is 6 months. So that means you must place the next order. We place the first order in January. The next order must be placed in July, 1st of July, after 6 months. That's what the result is saying. So any question with this? Does this make sense? Does this
Hello,
make
sir.
sense? Yes?
Didn't you say the formula for the reorder point is EOQ over 2?
EOQ over D for the reorder point. Mabuza?
Oh, okay. Thank you, sir. Thank you. I made a mistake. Thank you.
EOQ over D. So thank you. So correct. So I think we are all good. So the question now is, we can also have some questions, which we talk to the next slide. Then we'll now try to look at some questions in the book in line with these examples on EOQ. So we can also be looking at the sensitivity. How sensitive is our total cost if we deviate from the EOQ? Because some scientists are really passionate to say, fine, we know that the EOQ is the one that would minimize our cost. But if I want to take advantage of buying maybe something slightly more than the economic order quantity, like the example that we have here now, if you look at it, our EOQ was 250. If I decide to buy maybe 270, which is closer to, or 260, which is closer to 250, by how much will my total cost that I want to minimize deviate? So that I can now see if it's a small cost and if I want to buy a bit more than the EOQ, then what is the cost implication of that? And that could also help me making decision, maybe I should buy a bit more or a bit less than the EOQ. And that's the sensitivity analysis we are talking about there. So in slide 8, so you can try to check it. If you look at it, our EOQ and the way you calculate your, what do you call it? Your total ordering cost, when you work out how sensitive is your cost, you don't include the purchasing cost. Because we saw it even when we were deriving the formula that when we differentiate TC with respect to Q, DC was not, it was giving us 0 when we differentiate, meaning that it doesn't really influence how our ordering cost will look like, because whether you purchase an item now to use or you purchase it to keep, you still need to buy that money. So DC doesn't influence your ordering cost. What play a key role is your ordering cost and your inventory holding cost. Hence, we're able to differentiate them. So hence, if I want to work out how sensitive would be my cost, if I increase the order, I'm only focusing on my cost, total cost being ordering cost plus inventory holding cost. So for example, now, if I want to work out, for example, let me show you. And that is what you are seeing in that table. To say, if the question had asked you, I would put it on a Word document, the Word document that we're busy with. If the question had asked you, by how much will the, by how much will your total cost, that could be another question, will your total, let me just say another question. By how much will your total cost increase if Brain East Airline, by how much will the total cost increase if Brain East Airlines decide to purchase, you remember the EOQ was 250, to purchase 265 tail lights. So you see, they are trying to deviate a bit from the EOQ. So they want to see the cost implication of that. So if you want to calculate that, that is more of you running a sensitivity analysis. So, and the way we do that, what you need to go and do, let me just show you. If they have a kind of question like this in the test, you just take TC, you take the formula for your total cost equation, you bring it down. So you remember I told you DC doesn't have an effect because we have seen that, because even if you include it, it's still fine, but it doesn't really have an effect because when I calculate the total cost for the EOQ, let me just ask this first question. This is also another question you could be asked. Let's say you can also be asked, what is the total cost at the economic order quantity? So if the question is asking you this, we can leave it like this and still leave this C in it, but it's still fine. It doesn't matter because if you remove this C, it will still be fine, but let's leave it like this because it doesn't really, whether you leave it or you remove it, it's still fine. So if I want to find TC at, that's the first question. To answer this, if you have that kind of question in the online test. So they're asking you, the first question is asking you, what is your TC at EOQ? That's what the question is asking. So now you need to use your formula for the TC equation. We can still leave DC like I told you. If you remove it, it's still fine, but leave it like this. And let's leave it. So that means you go and plug and produce what is your D for the question. And in this case, now your Q, because you are looking at TC at EOQ, that Q will become EOQ. Take note of that. So that means this will become EOQ. Anyway, you see Q, because we are looking for TC at EOQ. So you modify the formula so that the Q will become EOQ. Then you can go now and plug and produce You remember your annual demand is 500, then your EOQ was 250, then the ordering cost for the problem, which is K, was 5. Then the EOQ was 250 that we have calculated, divided by 2, then H was 0.08, according to the parameter identified in the question. Then now you can put your annual demand into the picture. Your annual demand is 500, then times the price. They said each light costs 40 cents, so that will give you times 0.4. Because 40 cents is 40 over 100. So you can press calculator. What is the answer for this? So your TC at EOQ is this result. So what is the answer for this? Class, type your answer on the chat. What is your answer for this? Because that is also another possible question you can have in the test. Press calculator and tell me. And you are given the options. So you must select the right option. Yes, in the kinder.
So to say, why include DC at all if it doesn't have much impact on this formula?
Yeah, we can. That's something for me. I would just want us to leave it as see if we are working. So maybe in the test, I can tell you maybe if you like, because if you are looking at it in terms of maybe in the sensitivity analysis, you might remove. But here, when you are working TC at EOQ, you want to factor in all the cost. But if I want to look at it in terms of how sensitive, I know DC doesn't have a role, so I can remove it. Even if I leave it, it will still give me, whether I leave it or I remove it, it will still be the same result I'll get. So hence I'm saying leave the result as it, leave the DC there. Because whether you remove or you include, and when you do the sensitivity analysis, which is the second question, the result will still be the same. But when you work out the total cost, it's always good, it's a good practice to always also include the cost of buying the material, because that will give you the overall cost.
Okay, so
I
it's best you leave it
just
there
leave
in
it
both cases.
in both cases. Right. Yeah.
Okay, cool.
So the answer is 220, ne? Mabuza. Good. Thank you. So that means the answer here is $220. So you can have this question. So I believe you can do that now, also as additional question in the test. Then by how much will the total cost increase if Brain East Airline decide to purchase 265? So the way you 265K light, the way you calculate this, you go and find TC at EOQ first, which you have calculated. That's the first one. So what is your TC at EOQ? We've calculated it as $220. So because this is the question dealing with how sensitive is our cost from deviating from the EOQ. Does it increase very high than does it increase at a very high rate than the total cost at EOQ? Or it increased slightly? And that could also help me make decision whether I should increase what I order. Or maybe if I don't want to order exactly up to EOQ because I don't have enough money, then I must order something close to EOQ. But EOQ is always the best. So that is what we are trying to look at in terms of sensitivity analysis. So you find TC at EOQ first, which you have calculated. Then now you need to go and find TC at Q equal to, because now we are not dealing with EOQ because we are deviating from the EOQ. Find TC at Q equal to 265. And what is the result for that? We need to find that. And any result we are going to get now, it will be, you find the difference of TC at Q to be 265 minus TC at EOQ, the bigger one minus the smaller one, and that will give you the cost increase. And you'll be able to see whether the cost is high or low as compared to the cost at EOQ. So that means if we find TC at Q equal to that, we're going to take our total cost formula again, which we have seen as this. So I'm not going to make it EOQ because I'm dealing with Q, which is not EOQ. So I take this, I place it down, then I'm looking for TC equal to, now Q in this example is, Q in this context now is 265, so that means this will give me 500. Then Q now is no longer EOQ, but 265 times K times K. K is, we have seen in the question, is 5. Then Q is 265. 265 divided by 2 times H. H is the holding cost per unit per year, which is 0.08. Then you find DC. DC demand is 500. Annual demand is 500 multiplied by 500 multiplied by the cost price, which is 40 cents, which is 0.4. Now you can go and find your TC at so press calculator. What is the answer for this? TC at Q equal to that. What is the answer? Press the answer on the chart. What is the answer? $20.03, ne? So that is 220.03. 220.03. So you can see, now you can find the difference now, cost increase. And you can see it's very small. So that means if you deviate, and this is why sensitivity analysis is very important, because sometimes maybe you believe you want to order more than the EOQ, then you want to look at the cost implication of going beyond the EOQ. We have a significant gap in terms of the price. So if it's not really too much, then you can try to go beyond EOQ in terms of what you order. So that is if you believe that maybe there will be more customers, you believe that there could be some, especially when you're in an environment where the demand changes over time. So that means based on this, it will be cost increase equal to this minus TC at EOQ. So that means cost increase will be equal to 220.03 minus 220, which is equal to 0.03. So if you look at this, that is the answer. You can see it's $0.03. So that means the money difference is not too much. And that is the answer to that. So you can also have this question, then I provide option, know how to do that. So any question with this, does this make sense? So in light, thanking the kinder, yes. So in light of good, just to show you what they have done in the slide, I think that talks to the comment that maybe Ndikinda was raising to say, if you look at when they were doing their own sensitivity analysis, they didn't include the DC. But if whether you include or you didn't include it, if you find the difference in cost, if you include DC, in your difference in cost, maybe if you decide to deviate from the EOQ, the result will always give you the same difference. It's just that when they were working out here, they didn't include DC. So, but like I said, just to have for our own sake, let's just include DC because it's always give a reflection of all the total cost. So please let's do that. But even if I find the difference, if I've included DC, what is the difference if I order 220? What is maybe the difference in cost if I order 220 without ordering the EOQ? If I try to find the reduction in cost, including either DC or no DC, if I find that difference, it will still give me the same difference. If I subtract the difference of my total cost of this 20.16 from the total cost of 20.00, if you find the difference of this 20.0, where is that thing? 20.00 minus 20.16 minus 20.00, you can see by how much is that. And if you include DC in your calculation, you also get that 0.16 because DC is appearing on both, so they will cancel each other. And that's something, whether you include DC or no DC, when you do sensitivity analysis, it doesn't really have impact. So, but like I said, for the sake of uniformity, let's always include DC because it doesn't have any impact. So I think with that, let's look at some tutorial questions in line with this. Then maybe before we look at the examples, let's just look at more examples. Let me see, before we look at examples, let's look at more examples here, then we look at all the examples that talks to what we have done. So another way of computing EOQ, which is in slide 9, EOQ can also be determined from the context of, because some organization, when they work out their holding cost, they express it from the perspective of the dollar value worth of that inventory. So they try to work out this in terms of the opportunity that they are losing for tying that money down to inventory. So what is the opportunity cost associated with tying that inventory worth some money down? So when they do this, they use this formula, which is also similar to what we have as square root of, remember EOQ is square root of 2KD over H. So that means in their own case, the H in the formula will become P times HD, where the P in this case is talking to the cost price of the item multiplied by HD. The HD is talking to the cost of holding $1 in inventory for 1 year, which is more like the opportunity cost associated with you tying money down. So let's look at an example to see how this formula play out. But it's still the same concept as your square root of 2KD over H. So look at this example, you see how the H is playing out, but the other parameters are the same. So they said a departmental store sells 10,000 cameras per year. A departmental store sells 10,000 cameras per year. So that is the annual demand, which is D, capital D being 10,000. They said the store orders cameras from a regional warehouse. Each time an order is placed, an ordering cost of $5 is incurred, which is meaning that the K is 5. The store pays $100 for each camera. That is the cost price of the camera, which is C. And you see here, they say the cost of holding $1 worth of inventory, which talks to what we have said here. They say when you express holding cost in terms of value worth of inventory, then you have to use this formula. And the cost of holding $1 worth of inventory for a year is estimated as an annual capital cost opportunity because they express it as opportunity cost. like I told you, annual capital cost opportunity of 20 cents. So that HD in the denominator, you are seeing it as the opportunity cost, and P is the price of the item. So if you use this formula now, that means your EOQ will become square root of, which is that raised by half, 2K, we have seen it as 5, then D is 10,000, over P is the cost price of the item, which is 100, times HD is the opportunity cost. So that will give you times 0.2, because that is talking to the cost of holding $1 worth of inventory, which is expressed as the opportunity cost of 20 cents. So that 20 cents is 20 over 100 in dollar, which is 0.2. Then if you simplify this, then your Q will be equal to 70.71 cameras. But don't forget, you cannot get a fractional solution. You cannot order a fractional camera. Is that you order 70 or 71? So your EOQ can be either be 70 or 71. And either, because you know, even from sensitivity analysis, if you maybe get closer to EOQ, you know that the cost implication is very low. So you can either order 70 or 71. You can't order a fractional. So it's that you round it up or round it down. And that's why we said Q can either be, your EOQ can either be 70 or 71. Because you cannot have a fractional camera. So does this question make sense? Does it make sense? Does it make sense? Please, let's respond using the chat. So don't forget, you can also be asked to calculate what is the number of orders to be placed per year. You can do it now. And with this, you are also using your number of orders is D over EOQ. So if you are using EOQ as 70, so that will give you D, which is 10,000 over 70. So you can get the number of orders. They can also ask you when should they reorder, that is EOQ over D. So you can also do those questions. And they can also ask you by how much will the, in line with the first example we did, by how much will the total cost increase if you maybe buy 75 cameras or 80 cameras? You can follow the same principle like what we did in that other examples I give you now to do it. So those are possible questions or additional questions you can have in addition to what we have here. So before we go to cases of when we've got lead time, maybe we should just do the lead time, then we look at all the exercises in line with this. Let's just look at the effect of the lead time, then we look at all the exercises so that at least it speaks to all those exercises I will show you in the textbook that you must try. So I think now I want to go to what Indikinda was saying, to say, how about you are giving the lead time and all the assumptions of the EOQ was obeyed. It's just that the lead time was not obeyed. Let's assume that the lead time to place the order is maybe 3 weeks or 1 month or maybe 3 days or any value. So that means the EOQ has now been, one of the assumptions has been, is not obeyed. But other assumptions are, if the other assumptions are fine, but the lead time is the one which is the issue. So how do we know what are we supposed to order at a particular ordering phase? So the way these work, when the lead time is not 0, but the other assumptions of the EOQ is achieved, is that your EOQ formula, you still use it to determine the economic order quantity, still fine. The only thing that changes, like I was telling the kinder, is the number of orders will still be also correct. But when you reorder, that is where the question is to, and that is where the formula changes. So the way we do this, remember when for the example, for the EU, for the first example, when the lead time is 0, our reorder point is EOQ over D. And that is applicable when the lead time is 0 for that problem. Maybe it's not mentioned, that means the lead time is 0. But if the lead time is a particular value, that formula will no longer work. And the formula we use this time is, the formula we use, just to show you, we have 2 cases. We have 2 cases. So the way we do this is, and let me just tell you first, the formula we use to calculate the reorder point, we use annual demand times the lead time. So write it down. When you are dealing with a case where lead time is given, and that's why you see we are talking about the effect of non-zero lead time. And we have two cases that could occur there. And depending on any of the case, the general formula that talks to any of these cases, annual demand times lead time. So I'll type it on the chart. So the reorder point, which is like the general formula, then we see all the two cases and we see how we modify this formula. General formula is reorder point is, and you use this formula when you are dealing with a case where the lead time is not what do you call it? Is not zero. That's why you see most of the organization, they use the EOQ formula as it is, and they use the formula for that EOQ over D. Whereas their lead time is a particular value. Hence, they find out in those organizations that even though they are following the formula, sometimes they run out of stock, the order has not arrived. It goes back to the fact that they have not factored in their EOQ will be fine in terms of what to order, but they didn't factor in the lead time so that they know the right time to place the order so that they don't run out of stock before the order comes and they don't stock too much. So the reorder point is annual demand times the lead time. So, and we have two cases. How do we modify this formula to speak to the two cases? I will show you. So what are these two cases? We can have a case under the, when you have a lead time, when the demand during the lead time, does not exceed the EOQ. That is one case. And what are we saying? We are saying you must go and check for you to know whether it's case 1 or case 2 that you fall in, depending on the lead time value that you have in that organization to get the order. You need to go and check that lead time that you have in your organization to get the order. Go and check the value, look at the value and check whether the value is less than you computing the reorder point when the lead time is equal to 0. So that means even when we deal with case of lead time, we still need to compute the reorder point when lead time is 0 by using our formula EOQ over D. And check whether the lead time in the organization, is it less than or equal to that reorder point when lead time is equal to 0. If that is the case, it means that you are dealing with case 1. And it means that already with that kind of problem, that is very straightforward, you can already use the formula that I type in the chart by just saying your reorder point will now be annual demand times lead time so that you know at what time are you supposed to place the next order so that you don't run out of stock. So that at least you know for that remaining inventory left, before you finish consuming it, the order has arrived. You could factor in the lead time. So let's see how does that work with an example. So look at this example. So we are going to use the same example 1, which is that Brain East airline. So we are now trying to bring in, just like what Ndikina was saying, to say, how about if there was a lead time for the tails light, when we place the order for tails light, for example 1, if there was lead time, will our reorder point still be the same and EOQ be the same? So your EOQ would still be the same. You still use the formula, number of orders will still be the same. The only thing that will change is the reorder point. And how do we calculate the reorder point? So that's why now with that example 1, they are giving us more information, indicating that how about if there's a lead time to get the order, which now change the dynamics of the inventory problem, which says suppose that it takes 1 month of a shipment of tail lights to arrive. So that means the lead time is 1 month. So that means now you need to go and convert that to annual lead time, because you remember everything is in annual, because demand is in annual demand. So you need to look at that and first check, is this case 1 or case 2? The way you check that, you need to go and first calculate what is the reorder point at lead time equal to 0 for that same problem. You remember we have done this example And we have seen that the reorder point, based on our calculation at lead time equal to 0, if you go back to example 1, you see our reorder point is 6 months, which is half a year. So we need to go and check, was our reorder point, is our lead time for this question, is it less than or equal to the reorder point at lead time equal to 0? So we've calculated the reorder point already. If you have not calculated at lead time equal to 0, you calculate that first. But we have calculated it, so I want to check the result is 6 months. So we can see that lead time in this question is 1 month. It's less than or equal to the reorder point at lead time equal to 0. That means this is talking to case 1. But if we are going to see another case, we talk to case 2. If your lead time is more than the reorder point, you have to modify you are still going to use the formula, but there's a way you modify the result a bit to get the reorder point, which is talking to case 2. But the formula is still applicable. So, but luckily for this example, our lead time is 1 month, which is less than or equal to the reorder point at lead time equal to 0, which is 6 months. So that means this is talking to case 1. Then it's easy for us already to convert. You just convert this demand to annual demand. And don't forget you have 1 month. So if you want to make it yearly, that will give you have 12 months in a year. So that will give you 1/12. So that means the lead time is 1/12. So that you see, based on what I told you, the other point is lead time, which is 1/12 annual demand. Annual lead time times the annual demand, which is 500. And the result now is 41.67. So that means the other point is 41.67. So don't forget, we cannot have a fractional situation. So you can either select the result as either rounding it up to 42 or rounding it down. So you can see the lead time as maybe 41 if you round down, or 42, any of the two. And what is the result? This result telling in terms of the other point is saying, if you have placed an order of 500, as soon as you have consumed your inventory and you reach 41, then you must place an order immediately. So that at least you still have 41 left that you can continue consuming before the next order arrives, because at least that leeway of still having 41, you have something to consume and already place an order, then before that 41 finish, the order would have arrived. Unlike using EOQ straight, where now you run out of stock before you placing the order, then you are out of stock for some period before the next order comes. So does that make sense? Is it making sense based on what I've said to you now? Perfect. Mabuza, does it make sense? Akiwe, Echiada, I hope that makes some sense. Good. Good. So, and this is when it talks to case 1. Mwapelo, I hope it makes sense. Laiseko, I hope that also makes sense from your side. Nolutando, Metlape, Temba, I hope that makes sense. Perfect, good. So let's move on and let's see the case of case 2. How about if you have a case 2 where the lead time is greater than the reorder point at lead time equal to 0? So you can have that situation. Look at the same example 1. You are now changing the lead time. Suppose that the lead time to get the tail light is 15 months. So if you look at it, the lead time being 15 months, then we calculate our reorder point at lead time equal to 0. Remember, it has been calculated, for example, 1 is 6 months. So you can see the lead time is greater than the reorder point, which is talking to case 2. Anytime you have this, you still use the formula of annual lead time times the annual demand. So which is 15 months, you convert it together, will give you 15/12 times 500, and that is 625. So this will not be the reorder point. You still need to adjust this. How do you adjust this? Because it doesn't make sense for you to say the reorder point is 625 because the annual demand is 500. So you cannot have a reorder point which is more than 500. So anytime you have a case 2, you need to modify this case. And how do you modify this? You divide this result, this 625, you divide the result you get by the EOQ. You divide the result you get by the EOQ. So any result you get, which is 625, divided by the EOQ, which is 250, press calculator. So you say 625 divided by 250. If I press calculator, I'm pressing that just to show you how I'm getting that. 625 divided by 250, that is 2.5. So after you have done that, you see you get 2.5 as your result. Take the result you get anytime you have a case 2, divide it by the EOQ you have computed. So you have got 0.5, ne? So you take that 0.5, you see you have got 2.5, then you take the decimal part, which is 0.5. You multiply that result with your EOQ again, which is 250. You take the decimal part of the result, multiply it by the EOQ again. So any result you get would now be your reorder point, because you are trying to normalize that result. Because of that thing being more than the EOQ, the lead point at the reorder point is being more than the reorder point at lead time equal to 0. So you take that result, let me explain it again. Take the result you have got by multiplying the annual lead time times the annual demand. Take that result and divide it by the EOQ. And that's where we got 625 was the result, divided by the EOQ that we have computed for the problem, which is 250. Then that gives us 2.5. Take the decimal part of the result, because 2.5 decimal part is 0.5. So I take that 0.5, then I multiply it by the EOQ again, which is 250. So you see that result gives me 125, and that 125 is the reorder point. And that's how you see them getting that 125 here. So I hope that makes sense. Does it make sense? Yes, in the kinder?
So to say, why the decimal part? Why not the whole 2.5?
No, you cannot take the, isn't that we are trying to normalize, because we are interested in the fractional part. Because already that 625 was higher than the annual demand. So hence we are interested in the fractional part than the annual demand.
So what if it was 2 without any decimals?
No, it will always give you something, maybe 0.1, 2.1, or 2.15, or it won't give you exactly 2.
Okay. All right, sir. Thank you.
You're welcome. Because it's more like the result you are getting is an anomaly. You are trying to normalize it. And that's why it's case 2, because that lead time was being higher than the reorder point at lead time equal to 0. So it always gives you some portion of the decimal, whether it's 0.01 or 0.12 or something. So I think with that, we know how to solve this. So let's try to look at exam exercises that we can try at home. So we analyze some of them together in line with what we have done. And all these examples, let them be your friend in preparation for the test, please. So I'll try to analyze some of them with you so that it makes sense to you. So at least you don't sweat alone, but we have analyzed it together in class. And you just need to finalize it at home in preparation for the test. So I'm just going to stop sharing, then share the test book. Trying to go to the page. So the chapter we are dealing with is chapter 15, the ebook, which is deterministic EOQ. Please, can we mute? Please mute, please.
Yeah.
Someone is talking.
Indeed.
Mashlangu, can you mute? Please let me mute Mashlangu. Thank you. Yeah, it's fine. I'm coming. So we are dealing with chapter 15 in the ebook. That's what we are working on. So I'm going to the exercises we have there. Chapter 15, which is in page, let me see, 846. Let me go there quickly. I'll be with you. Yes. So I'm sharing it now. So we are dealing with this chapter, chapter 15. So that's what we have summarized into the PowerPoint, and we have talked about so far. So I will start with the first example. Go to page 858. Those are tutorial questions you need to try at home. They are very, very important. So let's look at question number 1. I hope you can see what I'm sharing. Are you seeing the textbook? Just confirm. Okay,
Yes,
good.
sir.
Perfect. So we'll analyze the questions together. I want to just help you. The other ones, I think I'll analyze those ones that I know they're a bit tricky. Then the other ones, I think if you follow the same principle, you can do it on your own. Make sure they are all your friend. So let's look at the first one. I think the first one is a bit easy for question number 1. But I just want to show you the part which is a bit funny there. They said each month, a gas station sells 4,000 gallons of what? Gasoline. Is that the annual demand? Is that the annual demand? Is that D? Is that really the annual demand, class? In the kinder, you asked you raised a point like that previously. Yes, you want to say
Yes,
something?
it is, but yes, it is, but it needs conversion to a year because it's in monthly basis.
In monthly basis. So the answer is no, because it's monthly demand that we're given. So you need to convert it to annual demand. I think Fulufelo, thank you. And Sukazi, thank you. So hence, when you read the question, don't just rush and say every time is D. Check. Are they talking monthly or weekly? So already you can see that is where students make mistakes. Some students will take that as annual demand. So that is not annual demand, that is monthly demand. So you have to multiply this by 12 to get your D. Because you know you have 12 months in a year. And they told you that each time the parent company refills, so now you know how to get D. You multiply this by 12, then you get your D. Each time the parent company refills the station tanks, it charges the station 50 cents plus 70, $50 plus 70 cents per gallon. So what is given there? Let's analyze it together. Is that K or H? If you don't talk, I'll also keep quiet.
That's K, sir.
That's K, that's the ordering cost, ne? Perfect.
Yes.
Good. So that is your K, which is 50. Some students will write 50 alone because it's 50 plus 70 cents, so that will give you 50.7. Don't forget. And they said the annual cost of holding a gallon of gasoline is 30 cents. So that is the H here now. You convert it to dollar, that's 30 divided by 100. Then from there, you know the parameters. Look at the first question. How large should the station's order be? What are they asking there? How large should the station orders be? Please talk. Don't keep quiet. I want us to do it together. Let's make mistake. Don't make mistake in test. How large should the station order be? What are they asking you there to calculate? If you keep quiet, I will leave it for you.
I think it's the number of orders.
Is that really the number of order? How large should the order be? You remember the number of orders is talking about how many orders should we place a year? How large should the order be? What are they being at there is being asked there? It's good that we are making the mistake now, but not to make the mistake in test. What are they asking you there? This is helping us. Because the one you are raising, Mabuza, in terms of number of orders, you can see B is asking you how many orders should be placed a year. That's number of orders. So what is A asking you? So are you saying I should leave it? It's fine. Let me leave it with you if you don't want to talk.
No, don't leave it. So we're not sure. Don't leave it, sir, please.
Yeah, then what do you think? Just tell me what you think. I want to correct what you think. I'm not going to tell you everything. What is that? English, how large should the order you want to place be? Yes, economic order quantity. Thank you very much, Sakiwe. Isn't that economic order quantity is how much you order? What is the size of your order when you place an order every time? And that is English. How large should your order quantity be? So that is EOQ, ne? So you need to use your EOQ formula to calculate that. Then after you determine your EOQ, the next question is asking you how many orders per year should you place? That's number of orders. You know how to do that. How long will it be? Will it be between orders? What is being asked there? You must see that one easily. We've talked about that.
Lead times?
You're saying?
Isn't that the lead time, sir?
No. You remember we talked about there are three things. We've looked at the two. There's the third one. Have you forgotten the reorder point? That is the reorder point. Because they are saying how long will it be between orders? If you look at the first example we did, that's also what they ask. To say, after how long should you reorder? That's what that question is asking you. That's the reorder point. And you know how to calculate the reorder point. So in this case, all these questions, you are calculating them assuming that the lead time is 0. So here they are saying, would the EOQ assumption be satisfied in this situation? Why or why not? EOQ will be satisfied because they tell you each month, so that means every month the demand is constant, which means that the annual demand will be constant, and all those other assumptions were obeyed. So already you can see from the scenario that the demand is constant. You are incurring an ordering cost of what do you call it, of 50.7, and you have an holding cost. We talked all the assumptions. Those are the things we can see. We tells us already that the EOQ assumption is obeyed. And they tell you that also those people sell those amount, meaning that shortage is not allowed. They want to meet the demand. So those are the things you can see there. Then the E part is the one which is very interesting. We talked to the effect of lead time now. Remember the effect of lead time? So they are saying if the lead time is 2 weeks, what is the reorder point? So remember now you have a lead time being pronounced. So that means you are going to, another question is if the lead time is 10 weeks, what is the reorder point? Assume that 1 week equal to 1/52 year. So that means what they are saying is 1 year is 52 weeks. So that means in this case, you are using your formula of reorder point because lead time is now pronounced here. So you use your formula of reorder point is lead time times annual demand, annual lead times times annual demand to do each of them. So I hope that makes sense. You know how to deal with that. At least I've shed more light. Does it make sense in terms of how to compute it? It's supposed to make sense if you have seen if you have understood what we have done so far. Good. So I'm just analyzing so that you don't sweat alone at home. So at least if you analyze the parameters together, you just try all those questions and you are fine. So let's look at another question, which is question number 2. And you can see how inventory is being applied here to a very funny question, to a situation where you are saving money in the bank. So look at that scenario where you are saying, they said the money in my account, in my savings account, money in my savings account, it earns an interest at $10 annual rate. Money in my savings account, it earns an interest at $10 annual rate. Each time I go to the bank, I waste 15 minutes in line. My time is worth $10 per hour. During each time, I need to withdraw $10,000. During each time, I need to withdraw $10,000 to pay my bills. Then the first question is, how often should I go to the bank? So if you look at this question, you need to go and identify what is your annual demand for money. So you can tell me based on the parameters there, what is the annual demand for money? What is your D? What is the D there? The annual demand? 10,000. Thank you very much. Correct. It's 10,000. Because this part, if you don't understand how to identify those, because we need to identify D, K, and H. So let's look at the next thing. Who can tell me what is the K? How do you get K from here? Because I know I need to withdraw money. And the question is asking me how often should I withdraw money? So if I need to withdraw money, that is looking at it in terms of me going there to order. So who can tell me what will be my K in terms of me ordering my money? If you look at it from that perspective, how will you get your K? What is your K value? You need to be very sober when you look at these things and look at it from the context of I go to the bank, I need to order, which is me getting money. So what will be my K? I see Sakiwe is typing. Someone said K is $10. Mabuza said $10. How did you get K as 10? Let's see. I see Sakiwe is saying, Sakiwe said, is it not the time it takes, which is 15 minutes? Yeah, you have an idea to some extent, Sakiwe. If you look at it, don't forget when you go to the bank, you need to look at, because if you read the scenario again, I see Mavunda say 2.5. How did you get 2.5? Let me see whether whether what you got.
Let me
Someone
try,
is saying,
sir.
yes.
All right. So how about if we convert the 15 minutes to an hour and then we multiply whatever number we get from that conversion times 10?
Yes, that could also, yeah, that could also work, correct? That could also work because they said each time I go to the bank, I waste 15 minutes. Thank you very much, you are right. Because now you need to convert, because I know that when I go to the bank, I'm spending 15 minutes. So I need to convert that 15 minutes to hour and multiply it by $10, because that will tell me the worth of the time I spend to get my money, which is the worth of the time I spend to get my money out of the bank, which is time to place the order in terms of the money, in terms of monetary value, which is K. Thank you very much. Correct. So that will give you, if you press calculator, 15 over 60. Am I right? 15 over 60. Thank you very much. And in the kinder, correct. 15 over 60, which is 0.25 times 10. And that is the answer that Mabunda was raising, which is correct, which is 2.5. So that means your K will be 2.5. Your K is 2.5. And don't forget, interest in this case is more like the holding cost per unit of the money you have in the bank. So your interest is your H here, which is 10%, which is 10 over 100, which is 0.1. Then from there, you can now go and answer all these questions. How often should I go to the bank? How often should you go to the bank is talking to the number of orders. Because it's not asking you how much you withdraw when you go to the bank. If the question is asking you how much you withdraw to go to the bank, that is your EOQ. If you look at it from, because we said EOQ is talking to how much inventory should you buy in a particular ordering phase. So that means for me to know how often should I go to the bank in relation to this question, I need to first determine how much should I withdraw for a particular order, which is EOQ, based on the idea of D, H, and K that we have seen. And from there, you now determine the number of orders based on D over EOQ. So you can see A is, actually you cannot determine A, B is the what you need to determine first, because B is needed before you determine A, but they just swap it around to confuse you, because they said each time I go to the bank, how much should I withdraw? That is the EOQ. How often should I go to the bank? That's the number of orders. Then the C part, I will leave it with you to try it. They said if my need for cash increases, will I go to the bank more often or less? So how do I do that? Who has an idea? Think about that. If my need for cash increases, will I go to the bank more often or less? That is sensitivity analysis, correct, in the kinder. So that means what you do there to help you to be able to do that, to be able to answer that kind of question, because they're saying if my need for cash increases, so that means you need to increase your K, because that means now you need to go to the bank that which is talking to pay, you going there to order. So that means you can change your K from 2.5, run an experiment, because currently your K was 2.5. If you make your K is $2.5. If you make your K now to be $5 or maybe $4, any value which is higher than the current K, and go and now calculate your number of orders when K was 2.5 based on the initial question, and when K was maybe 5, when you have increased it, and now go and check whether the number of orders, because will I go to the bank more often is talking to number of orders or less. So calculate number of orders for your new K and compare it with your number of orders for the current K for the current question and see whether it increase or decrease. And that is how you'll be able to conclude. So you need to experiment with the parameter of your K, which is higher than the current K, and do that analysis and check whether it increased or decreased. And that's how you answer that. Then if the interest rate also rise, so you can experiment by also changing the interest rate from 10%, which is your H, which is 0.1, currently is 0.1. You know, they're asking you, will I go to the bank more often or less? So you know the number of orders for that based on the result of A. So increase it to maybe 0.15 as a new experiment and check whether your number of orders increased or decreased when you maybe increase it to 0.15 or 0.12. So far is more than 0.1. So far is more than this 10%. So then you check whether you'll be able to answer that whether you go to the bank more often or or less. So then the last question, if the bank add more tellers, will I go to the bank more often or less? Who can tell me what will be the trick for that? Which parameter are we supposed to run sensitivity analysis on? If the bank can increase the number of tellers, which variable will be affected in the scenario? If the bank add more tellers, which of those variables in the scenario will be affected? Will this new strategy impact? If the bank add more tellers. Don't forget, currently the wait time for me to withdraw the money in the bank is 15 minutes. So if the bank add more tellers, what will happen to the wait time?
So K will be affected, sir.
You're saying?
K will be affected.
K will be affected. Thank you very much. Because that wait time would now, if I've increased the teller, that wait time would have now reduced from 15 minutes maybe to 10 minutes or 8 minutes. So you can go and change the value of the wait time and recompute your K for that. Because the implication of increasing the teller means that the wait time, because now we have more people to handle the customers. Are we together there? So K will now have reduced if you look at it from logic. So just experiment by changing your K from 15 maybe to 10 or 11 and compute your new number of orders and try to see whether it increase or decrease. So those are the questions. Please try those questions at home. Then try question number. Let's look at number 3 also together, because I always want to analyze all these questions. But I think all these other ones that I'm going to say after this, they are straightforward. They are things you can attempt. But let's look at number 3 also together. They said, so we've looked at 1 and 2, so make sure you finish them at home. Father Dominic's Pizza Parlor. So you can see how this inventing concept can be applied in various operational problems. So you can deploy all this if you work in this kind of environment. If you are working in banks and you want to advise your customer the rate at which they must come and order so that they minimize how often they go to bank and all that, because they have other this thing. You can deploy this concept to advise your customers. But some of them are not really even wise in terms of knowing how often should they come to place orders or using other applications that are there. So in that case, they are making wise decisions and using their time judiciously. So, and that could also help you in terms of also optimizing how you render service for the customers. So let's look at another example. Like I said, Father Dominic's Pizza Parlor receives 30 calls per hour for the delivery of pizza. So you can see how this is applied in KFC or any other. So if you work in KFC or you work in all these retail shops and you need to maybe render services from clients that gives you call, you can apply this concept to improve service delivery. So let's look at that scenario. Father Dominic's Pizza Parlor receives 30 calls per hour for the delivery of what? Pizza. So he's receiving 30 calls every hour for the delivery of pizza. Let's read the question first so that we can identify correctly the D, the K, and the H. They said it cost Father Dominic's $10 to send out a truck to deliver the pizza. It cost Father Dominic $10 to send out a truck to deliver the pizza. It is estimated that each minute a customer spends waiting for a pizza costs the pizza parlor 20 cents in lost future business. So that means they've analyzed the cost of waiting. If you allow the customer to wait too long, think about it, some people order pizza from home. So if they have ordered and they are waiting for long, maybe they won't buy from you anymore. So, and they have worked out the cost of waiting, which is a function of maybe how many customers they lost over time. owing to maybe their current waiting time to produce the order and get them delivered. So now, and they use that to calculate the cost of waiting, which they have calculated as 20 cents. 20 cents in lost future business. So the question now is, how often should Father Dominic send out a truck? And this can be applicable. You remember when you go to all these shop, what do you call it? You go to all these KFC and what do you call these other ones? All these Chicken Licky and all those. Don't forget they've got all these bike people that delivers products. So you can apply this concept to know how often should each of these bike people go out to deliver products to the customer so that you don't lose customer. So this kind of problem can be applied in that context in terms of bike man scheduling in all these KFCs and all those. So who can tell me what is our D here? What is our D for this problem? So how often should Father Dominic send out a truck? What is our D? That will be send out a truck, right? The D, let's see what you are saying. D is 30 because you are looking here in terms of hourly, because you cannot convert it to annual in this context because we want to analyze how many trucks you go out on hourly basis. So you can look at it from per hour. So look at the D as hourly demand and the D will be 30. Thank you, Filipello, correct? So then let's see what is our K in this case. K is 10, correct? Because they said it cost Father Dominic $10 to send out. Yeah, so that is K. It is estimated that each minute a customer spend waiting for a pizza, it costs the pizza parlor 20 cents. So what is our H in this case? What is our H? What is our H? I'm waiting.
It's 0.2, sir.
0.2, which is 20%, yeah. So with that, I think you can finish this at home. The first question, how often should Father Dominic send out truck? That is number of orders. You know, we deal with that. What would be the answer if a truck could carry 5 pizzas? So they are saying, yeah, they're asking you if Q, because this is talking about the EOQ, if EOQ was 5, then what would be, how often should, how many trucks, how often should Father Dominic send out trucks? So that would be number of orders equal to D, which is 30 over this 5. Because that would be this number of orders that they can, number of pizzas that they can deliver, and that will tell you how many orders should they place. So I think that's supposed to be very straightforward. So those are the 2 questions under 3 and 3B. Then when you get home, also try, I think those are the ones I wanted to analyze. Question number 11. Let me see whether I skip another one. Try question number 11 is fine. 11, let me see. Question number 11. Number 11, number 13. I think those are the ones, 11 and 13. Those are the ones left. So I think based on what I have said, let me echo it again. It's question number 1, question number 2, question number 3, then question number 11, and question number 13. Let them be your friend. So I think with this, we are good. I don't want us to start a new concept. Let's go and digest this. And I've told you all the possible questions that you can have in test. So just to highlight again, our test scope will end here for the online test. Don't forget our test is coming up next week, Friday, and next week, Tuesday. What I've decided to do, we won't have a class so that you can have time to prepare for the test and also have time to push your assignment and also prepare for your test. So at least it also helps us to really get ourselves ready for the test and also push the assignment. Time is not on our side. We need to fight. So on Fridays and the online test, and don't forget I've made the sample of the test available. So you have seen it now. I've even echoed all the possible questions in line with what the way the question could be structured in line with what you have done today. Make sure you practice all of them. So please make sure you do that. And the test on Friday will be available at, I want to check with you, should we make the test available at 5 p.m.? Do you want us to start it early or you want to still make it at 6? And it's going to be 2 hours, 15 minutes. So I just added 15 minutes. Please make sure you are right in a place where the network is very good. 6 is fine, eh? Okay, 6. Please make sure your network is very good. Don't come here to say you are right. Yeah, no, I got kicked out. Don't write in a place where the network is not good. I won't listen. Make sure you are right in the place where your network is good and everything is fine. And you are going to have 30 questions. I told you, you can see the way I'm structuring those questions in the sample online test question. I can have one case scenario, maybe 10 questions. We talk to the steps, like we saw with the formulation of EOQ model. So it talks to all the steps. So, and I give you answers to all the steps. Then you choose the right answer. So, but I will try to also, what I would do, I would confirm the number of case scenarios you have for the test for you. Hopefully by Wednesday, I would have confirmed that. But I think the case scenario is always between 4 to 5 case scenarios. So you can find one case scenario repeating itself, coming to you maybe 8 times or 6 to 8 times. So when you see a scenario for the first time, like all these inventory problem we are solving, you must solve it the first time. You can spend 20 minutes. I'm just saying if it's like the probabilistic dynamic programming, don't forget it takes time to compute. So don't panic. Get a sheet of paper, solve the problem. If it comes to you for the first time, you know the question I will bring is not new. It's those examples, those tutorial questions. If you have practiced them, you are fine. So that case scenario will come to you when you see it for the first time, especially with probabilistic dynamic programming, solve it. Spend 20 minutes. Because that case scenario on probabilistic dynamic programming, it will come maybe 8 times. So make sure that when you solve, don't tear the paper. Have the solution with you. I'm telling you the trick of how to do this test. You have the solution with you, you keep it. Don't forget I told you the case scenario can be, and you answer the first question, maybe after that 20 or 30 minutes that you have used to solve that problem. Look at the step that I'm asking that question on in your solution, then pick the right answer, you move on. Don't forget the questions will be randomized because I know some of you might decide to sit together. So even if you see together, it won't help because your own question 1 can be question 30 for another person because the questions are randomized. So if one case scenario comes to you for the first time, solve it, 20 minutes is still fine. Then if another case scenario come again, because maybe that same case scenario is not appearing because of the randomization, if a new case scenario come, also solve using 20 minutes. Don't panic and keep the sheet of paper somewhere. So anytime a new case scenario comes, make sure you solve it and keep the result because that case scenario will still repeat itself as you are doing the test maybe 8 times or 6 times or so. So that when they come back again with another question on one of the steps to your computation, you already have the solution. You just take the solution and go and check what am I asking based on this computation. Then you select the right answer. So as I'm saying, you don't need to panic. You just need to solve it, have your solution, because all the questions I'm asking, they are talking to the steps to arrive at the solution. In line with all the way I've said the question could be phrased, and in line with what you have seen in that sample online test questions. So then from there, if you do that to the letter, you'll be fine. You finish even in 2 hours or even before that time. So don't panic when the scenario comes first time, spend 20 minutes solving, have your solution so that when they are coming back, you already have your solution. You're just checking within 1 minute. If you know your solution, you can quickly select the answer for the others as they come back. So I hope that makes sense. I'm just giving you tips of how the question is going to come when you see it. Yes, Indikinda?
So you're saying, sir, the test will end here where we ended today.
Yes.
So it's gonna start where the
It's
first
starting
test
from
ended.
probability concept. Sorry, it's starting from probabilistic dynamic programming from mixed distribution. You remember, that is where
Yes.
we started after the first test. Starting from there, mixed
Okay.
distribution, probabilistic dynamic programming, everything up to what we did today, which
All
is
right,
the
sir.
effect of non-zero lead time and all those. All those examples, tutorial questions that I gave you on probabilistic dynamic programming, let them be your friend. I actually the tutorial questions, examples, don't forget because you are sitting at home, I will not really bring example. So tutorial question must be your friend. So I might change the parameters here and there, but if you know how to do those things, the procedure is the same, then it's easy. Even if you're the ones you have practiced, just follow the principle to the letter, then you're fine.
Thank you, sir. So we will only be left with one test after this one.
Yes, we only be left with one test, which is the summative, and that one is on campus. It's non-negotiable.
That one is on campus. All right. So
Yeah.
approximately what date, sir?
No, I just need to confirm with you. It will be around, I think that towards the, what do you call the thing? It will be around early June, somewhere there, if my memory serves me right, or even before, maybe towards the end of May or early June.
Okay. All right. Thank you, sir.
Somewhere there, but I will confirm. Because after this deterministic dynamic programming, we have, after these deterministic inventory models, we have probabilistic inventory model, then we have the last model. So I think by the end of May, we would have finalized, then I think we have a week. I think that test will be after the, if you check the calendar, it will be after the study week, if my memory serves me right, but I will confirm with you.
Thank you, sir.
Hello, sir.
Yes, Mabuza?
Sir, I have been trying a question on the tutorial document that you sent on probabilistic production or service planning and scheduling problems. Do you remember?
Yes, you have been doing what?
I've been trying to solve question 1 of that document, but then I don't understand it. Sorry?
Yeah, you have to send your solutions to me. Anything you have, send it. Let's check, then our advice.
Okay. Okay, must I send it on your email?
You must send it to my email because I want
Okay.
to see what you have done. Then I will tell you where your mistakes are.
Okay, thank you, sir.
You're welcome. So that's what I'm saying. Send your solutions, and I advise you work in groups because it's better to always work in groups. If you can work in groups of 3 or 4, the group leader can send me the solution, then I check, then I tell you where the mistakes are, then you'll be fine. Because you know, okay, I said these are the mistakes, then you correct it, then before the test, you are sharp. But don't send it a day before the test. Send it a few, at least from early next week, so that I also have time because I'm also busy with other things. So work on it over this weekend. So I hope that is sharp. Perfect. Any other question?
One last question, sir. Yes, sir.
Yeah.
This one is with regards to the report that we are doing. So section A and section B, they will have two different organizations. How do we then incorporate those organizations into the segments of our report? Like, for instance, we have introduction. So how do you then fit two information from two different organizations in one introduction?
Now that is report writing. But you isn't that you're introducing, you talk about, you introduce to say maybe section A is looking at this, section B is also looking at this organization, we deals with this and this and this. It's all about report writing. You introducing what they.
Okay, so you'll do them differently and say it's like section A is this what it says, and then section B this is what it says.
Yes, isn't that you're introducing what the report is all about?
Okay. No. I was trying to how to fit the information together, sir, because it's two different organizations. See?
Yeah, you introduce it as such to say this assignment is all about maybe this and this. It was all about this particular organization. It was all about maybe applying what in this organization, and I got this and this and this. And the second aspect of the assignment looked at maybe applying what in this organization with this with 1, 2, 3. Because you are introducing, so you can still always introduce what the study is all about, even whether it's 2 or more.
Perfect. Sir. Thank you so much.
Yeah. Any other question?
Yeah. Say on section A, must it really like be specific in a service organization, or it can be a manufacturing organization, then they provide a service?
It must be, you remember what was the question saying? Was it saying a service, ne? But if the question, maybe the organization,
service.
Yeah, if the organization is producing product and they are rendering it as service, is fine. But just stipulate it as such properly.
Okay, thank you.
In terms of delivering that product to customers, as it's also part of rendering service, but stipulate it clearly in the report.
Right, noted.
Yeah, perfect. Any other question? So I think with this, we are very good. We have really stretched it. Let's call it a day. Thank you very much for joining, and we would continue from here. We'll continue from here when we come back. And when we come back, we still have, we need to push deterministic dynamic programming and try to finish it. Let's see, we still have a lot there. Because when we're going to come back, let's see. I just want to be sure. Because we still have to push this. Let me see. So we are going to come back because we are writing next week. So I think we'll continue on the 7th. Yeah, it's fine. I think we're still fine. If there's a need for extra class, we do the extra class, but I don't want to stretch you because I know you are still busy with assignment. So if there's a need for extra class as we move on after the assignment, we'll just do that. But for now, I don't want to have extra class so that, because I know you are also still busy with the assignment. So I think we'll just continue after the test, which will be on the 7th of May. That's when we are meeting the next class, so that we continue pushing. So I hope that makes sense. But if there's a need for extra class, we see it then. But I don't want us to have, because of the assignment, I know we are busy. So, but when the need arises for that, please take note, we have that extra class. And don't forget, like I told you, the recording now, it won't be a video, it will be a link, because the university say we must put it on OneDrive and provide the link. So that's what you will see going forward, especially for this class that we just finished. So you are seeing a link, and that link, it will be accessible because they said It will be there. If you open, you'll be able to access our OneDrive as a university and get the recording there and be able to play the recorded class session. So I think with that, the last thing which I want to say quickly, please, those people that have not done the teacher module evaluation, please, is due tomorrow. Please go there. You see teacher module evaluation on ULink and try to evaluate the module itself. You are going to fill 2 documents and evaluate the teacher itself, myself as the teacher of the module. So please, you need to complete 2 documents on or before the end of tomorrow, please. So I think with that being said, let's call it a day. Thank you very much for joining. Have a nice evening. All the best with the test.
Thank you, sir. Bye-bye.
Bye-bye. But I will also communicate, like I said on announcements, you will see where I will tell you where to get it. I also wanted to say this quickly before we leave. The link to access the test, you see it as a section on Moodle, the way you see your unit. Then you can click that section, then you'll be able to access and start the test. But I'll also highlight it in the announcement. Perfect. Have a nice day. Bye for now.